Hello and welcome to our session, VMware Cloud Director and NSX Best Practices. So, who are we? What are we doing? My name is Reinhard Portman. I'm working for Com Division. I'm lately working mostly multi-cloud, NSX, SD-WAN, and also have a strong background on end-user computing. Myself, also Toby, we are long-running VCIs, so you can ask us about mostly everything. So, handing over to Tobias now.
Thanks, Reinhard. Yeah, my name is Tobias Paschek. Just call me Toby, which is much more easier. I'm also partner at Com Division. My main focus area is the whole cloud networking, but also, on the other hand, the security world inside cloud provider spaces, but also in traditional enterprise spaces. Thanks, Reinhard.
Okay, so let's get started. We have a small agenda prepared for you guys. So, who are we? What are NSX best practices, NSX migration updates, and at the end, stories from the field out there. Well, let's get started. We are on a schedule. Okay, Com Division Group. Founded in Germany, 1996, so it's 1996, so that's not that old, but old in the IT business. So we have offices in Germany, Austria, where actually we are located, in the US and also in Belgium. We come out as a strong VMware partner decades ago, actually already. So we are an architecture business. We also educate because every one of our partners is actually also a VMware certified instructor. So designing, education, and also then at the end of the whole story, operation. So we do this. Partnership with VMware is long running, years back, decades back actually, and lately we also are partnering up with AWS. So most of you know the product, VMC AWS is hot, it's good. So NSX best practices. What will we talk about? We will talk about tier 0 design, placement of the edge nodes, where do they go? Sizing of edge nodes, and NSX advanced load balancers. Well, let's get started. So, here we go. Yeah. Those things you always should think about before you start anything in the VMware world or any other software, as a matter of fact. Check the interop metrics. Well, because all the things, and even also in the designs, all the stuff you do not think first and foremost, well, they will hunt you down and then they will bite you in your six. Most likely, right? So, check that out. So what do we have here? We have our shared tier 0 from a provider's perspective. Tier 0 is provider managed. Per tenant, we have our tier 1 edge, well, gateway to be exact, and we do the network routing outside. So that's one of the most common use case. Works pretty fine. So what else do we have? If this works, we have separated VRFs inside one tier 0 gateway. So basically what we see here is we have one shared provider-controlled tier 0 gateway. Per customer, we run a VRF. The routing is done inside the VRF per customer. No overlapping, a perfect mix and match for many workloads. You see also different providers and customers up there. You see the edge IPs, all that stuff which needs to be set up to make this thing work. So, on the next slide, I hand over to Tobias.
Yes, thanks, Reinhard. So, one of the interesting topics at the moment, and I came across with this really many times now, is the placement of the edge nodes. So, as always, it depends. That's the only answer I can give you out of my head right now. It depends what solution you are utilizing in your data center at the moment. If you have already changed your network architecture to a spine leaf architecture, then maybe it makes sense that you place your tier 0 gateways, your provider managed tier 0 gateways to be honest, as near as possible to a border leaf or to my next upstream device. Can be a firewall, can be a router, can be whatever you have. If you still are running in a let's call it traditional, I don't like the word traditional really, but if you still are utilizing a traditional network, so a core access distribution network, the tier 0 gateway can be placed wherever you would like to have it. But also here, my personal recommendation is to place it as near as possible to your next upstream device, because then you can easily achieve a better throughput and a better utilization of the edges. On the other hand, we have our customer. The customer each customer inside the Cloud Direct environment utilizes his tier 1 gateway, as long as we are not talking about any kind of external or imported network. So as long as we stay on the whole NSX-T or whole NSX story, each customer will utilize a tier 1 gateway. So the placement of the tier 1 gateway for the customer, where we have our stateful services like firewalling, like NAT, like IPsec policy-based VPN, and so on, makes absolutely sense to have it placed on the workload cluster, because I would like to achieve that all of the traffic, which maybe needs to go via tier 1 gateway, needs to walk over my whole data center environment and comes back to another virtual machine, maybe running on the same cluster. So it makes sense to have it placed as near as possible to my customer workload. Coming back to what we have seen before from Reinhard, there's a third option available, the dedicated tier 0 gateway. So Reinhard mentioned that there is the shared tier 0 gateway, so where we provide uplink connectivity via NAT to all of our tenants. Then he mentioned the tier 0 VRF, where we have our provider managed tier 0, but each child tier 0 VRF can be then utilized by the customer. And the last one is, we have also the opportunity to provide really a dedicated edge cluster for just a single customer, because as always, also here VCD cannot do any magic. As always, a tier 0 can only run on a single edge node cluster. There is no possibility to have multiple tier 0s on the same edge node clusters, not talking about VRF, because with VRF we get the possibility. But also here, it depends what we have. If the customer comes, for example, with his dedicated SD-WAN solution, for example, VMware's, or if he comes with an MPLS line, it maybe makes sense to place it on the customer workload cluster. If I say, hey, no, he's just providing, he gets dedicated internet access from us as provider, and he would like to connect to the external stuff, then it makes sense to place it to my border leaves, to my core routers, whatever we have here. Also, since Reinhard and I will do some myth-busting today, is the sizing of the edge nodes. I know that many says, hey, let's go with extra large, or let's go with large at least, but I don't care about medium or small deployments, because I would like to have the as large as possible. If you have a look to the official VMware documentation describing what the extra large edge and also the large edge is capable for, you will clearly find here the wording suitable for total throughput required for layer 7 load balancing. Hey guys, layer 7 load balancing on NSX is dead. Layer 7 load balancing will be replaced with NSX ALB, and NSX ALB comes with his dedicated service engine, not running directly on the edge node. Also, the next thing we have, if we have a high amount of IPsec VPN sessions, also here from a provider perspective, from what we manage as a provider, I just care about my tier 0 gateways. The whole VPN stuff is happening on the tier 1 gateway from my customer, or maybe if the customer have a VRF, then on his VRF. So also here, it makes not really always the big sense that you go with the large or with the extra large edge node, because you will lose a huge amount of memory, you will lose a huge amount of CPU. And please always have in mind, ECMP in NSX is still capable of having 8 edge nodes in parallel. All of them must have the same size. So if you deploy a tier 0 ECMP-enabled edge cluster, you have at least 8 times 8 CPUs and 8 times 32 gigabyte of memory just for routing. Because what the provider tier 0 is, his main reason is routing, providing routing connectivity to my upstream and providing routing connectivity back to my tier 1 gateways. So that's the reason why I highly recommend to really think about how is my routing design looks like, and does it really make sense to have this high amount of CPU and memory for my provider tier 0 gateway. Everything else, so my tier 1 gateways for my customers, okay, we are absolutely fine to go with large or extra large because the customer is utilizing NAT, the customer is utilizing the firewall, the customer is utilizing IPsec VPN, and so on. But always having really the large stuff deployed makes no sense. Also, the second myth is related to the bare metal edge. Yes, there is a bare metal edge node available, so you can take whatever hardware vendor you would like, an x86 standard server, bring in some specialized network cards, bring in some specialized CPUs and memory, and then you can deploy an edge node or the NSX edge directly on your bare metal server. Also here, having a look to the official VMware documentation, VMware clearly says the bare metal edge only makes sense if you have high latency applications in your environment. It makes no sense for just pure routing or just pure firewalling. It makes only sense if you really have latency sensitive applications, or, and this is what you will not find in the documentation, if you really have the possibility that you are connected with more than 20 gigabit to your internet line, to your MPLS network, to whatever, because the virtual edge has a routing limitation roughly about 20 gigabit per second. I have seen 23 as well, but officially it is 20 gigabit per second. What the virtual edge node is capable of, the bare metal can do line speed 100. So if you really need the high amount of throughput as well, okay, then we can go with the bare metal edge. But everything else, there is no difference between a virtual edge and a bare metal edge. And I have seen this on many providers saying, hey, but we need to have bare metal edges because this is the way to go. It's not the truth. Let's come to the next chapter or the next topic, NSX-ALB. New fancy stuff. No, not really, to be honest. But Reinhard, what's your opinion about the NSX-ALB?
You all know it was acquired by VMware a couple of years ago, pre-COVID, right? It's the only supported load balancer in the Cloud Director when you're using the API. Well, I think you want to use that because no one wants to do everything manual, right? On the other hand, it provides you load balancer as a service. You can sell that to your customers. It integrates nicely into the tier 1 gateway. Features like web application firewalling, they're on the roadmap. They will come, certainly. As always, continuous development. So you also could use NSX-ALB to front it in front of your VCD cells and have the load balancing feature in front of your Cloud Director, also as a web application firewall when the features are there, or you can put them through. And NSX-ALB, from a networking perspective, we were here yesterday, it's a mandatory feature when you're running Kubernetes as a service and you want to sell that service to your customers. So it's a condition sine qua non. You cannot do it without it, right? So what's the next slide, please? Yeah, well, here we see Toby.
Yes.
Take over.
How is NSX-ALB working from a Cloud Director perspective? Cloud Director is now finally capable, or finally, since at least 4 versions to be honest, is capable of connecting back or talking back to the ALB manager. So there is a direct communication part between Cloud Director and NSX-ALB. You just need, from a provider perspective, to enable load balancing as a service inside your tenant, and then the tenant can start to consume his load balancers. So there are different options available. We have talked about it yesterday, how the service engine, because the service engine is the data path of inside NSX-ALB. So these are the guys where the whole load balancing is happening. And then the service engine can be deployed per tenant or can be deployed in a shared way, depends what you would like to achieve. And the service engine connects back to the customer tier 1 gateway. So the service engine gets an interface on each customer's tier 1 gateway, the so-called service interface on the tier 1 gateway, And then the whole load balancing traffic is running on a shared network between the customer network and the customer tier 1 and the NSX ALB service engine. So as Reinhard mentioned before, at the moment the only solution VMware and also Cloud Director can offer you to really provide load balancing as a service, because it is fully integrated and more features are ramping up and coming from the NSX ALB UI to the Cloud Director as well. Last but not least, last year we started talking about the migration from NSX-v to NSX-T, or to NSX to be honest, because the final name is now on the decided. This is just NSX without the T. Migration tool 142 is available and is the absolutely clear tool to go. Why? We have now really finally get the support for exclusion in the firewall rules, or also for negotiated sources in the firewall rules. We can have now firewall rules with multiple ports, which was a full mess before, that we were not able to migrate firewall rules where we have multiple ports in the same rule set. We have the support for migration of virtual machines without the network interface. Some of you maybe will laugh and say, hey, okay, why should I have a virtual machine without the network card in my VCD? Talking about offline root CAs, if the customer have deployed an offline root CA, it was never connected to any network, which is the best practice by Microsoft. You're fucked up, to be honest, because you cannot migrate, you haven't been able to migrate, and this is a feature I requested, to be honest. You cannot migrate those customers, you need to export it before and then import it again, so it was a full mess, and now it is supported. And also we have finally got the whole NSX ALB support, and with the latest release of the tool, so with the 142 version, we have now also the ability to provide SSL pass-through in the load balancing application profile, which was originating from an NSX-v perspective, the only or one of the easiest solution how you can provide SSL offloading. It was not possible before the latest release of the NSX migration tool. Time is running up, to be honest. 10.5 will be what I heard from VMware, the last version where NSX-v still will be supported. To be honest, it is not supported anymore. It is still possible that Cloud Director can utilize and can talk with NSX-v. So the next release, so talking about 10.5 whatever, or maybe 10.6, will not be able to talk with NSX-v anymore. So it is really time that migrations from NSX-v to NSX and Cloud Director needs to be done. Also here, as always, verify if your tool is working in your environment. So as you can see, at the moment, the actual migration tool is not capable of talking with NSX 4.1.1.0. Okay, then we maybe need to utilize another version, or we maybe need to go one step back. And also from a Cloud Director perspective, please verify that the tool is supported on your Cloud Director as well. Yeah, some stories from the field, what we have seen in the past couple of months. Yeah, one big pitfall, and this is not related to VCD, that is really related to NSX, is please be aware that NSX at the moment only supports a one-to-one port relationship in a NAT rule. So talking, for example, of passive FTP, where you need to open a whole range of your passive ports, which is at the moment not possible in NSX. So then you really need to open, or you need to create 400 NAT rules saying, okay, my passive port starts with 5,000 and should go up to 5,040. You need to really instantiate at the moment 40 NAT rules, which is a little bit of a mess. Hopefully gets fixed by the BU in the next couple of weeks, because I have two customers where we need to create more than 5,000 NAT rules. Not the best idea. IPsec route-based VPN is on the roadmap, but still not supported on a Tier 1 gateway. If you have customers saying or heavily relying on IPsec route-based VPN, only option is to go with a dedicated tier 0 or with a VRF tier 0. Then since version 4 of NSX, we have now the possibility of utilize IPsec route-based VPN on a tier 0 active deployment as well, because this is something which has been introduced with NSX-4. Edge nodes and CPU reservation, also a funny story from the field. I had one service provider in Europe calling me on Friday afternoon saying, hey, I have packet loss, I have packet drops, my whole environment is not working anymore. And he said, okay, let's see what's going on here. He onboarded a huge bunch of virtual machines for a single customer. And then after he onboarded all of the virtual machines, he figured out, okay, or we figured out, that he deleted all of the reservation of the NSX edge nodes and to power on the virtual machines. And yeah, ESX is doing what ESX is doing. He's overcommitting CPU, he's overcommitting memory. And something an edge node is not really funny, or what an edge node does not really like, is if CPU is overcommitted. Then the whole routing process begins to start as soon as NAT or any other stateful services come in. It really becomes a full mess. So please, please, please do not remove reservations, and always have a look into your utilization of the ESXIs where the edge nodes are running.
Overcommitment was always a good idea.
Always a good idea. I just named it crazy network designs. To be fair, not talking really about crazy network designs, talking about an opportunity, or talking more or less about an opportunity, what can be done with the migration from V to T, that you rework maybe your network environment. This is also something I've seen a few days ago. A customer who have done everything absolutely correctly for NSX-v, talking about multiple distributed switches, that he can separate DMZ traffic and dedicated uplinks for multiple customers, which was fine for NSX-v. And he was not well able to do it for NSX-T or to do a network redesign, because he said, hey, then we need to talk with the network teams and so on. Let's just migrate it as it is. This migration runs now since, I think, at least a half a year, and we don't make any progress, because we always step into the next pitfall and figure out the next pitfall, which can be easily solved if we just would do a quick network redesign and everything would be fine. So this is something I can highly recommend, that you also have a look into your network before you start with the migration. Last but not least, before we finish, tier 0 proxy up. Also something some customers maybe have overseen, or maybe it was not well documented as well. So let's blame it on VMware. Yes, with the version 4, proxy up is possible on an active configuration, but to reconfigure from active standby to active, you need to disconnect all of your tier 1 gateways. And then please do not call me on a Saturday morning and say, hey, nothing is working anymore, because you have forgotten to reconnect the tier 1 gateways. So this is something which needs to be done manually. There is no automated way in the NSX UI. So this is something which needs to be done manually. And as always, before you ramp up a new rack, before you start consuming new hardware, please verify if the maximum transfer unit is configured really end-to-end on the whole new equipment. Also here, having a customer saying, hey, I just got my new rack and everything is has been deployed and everything is working fine. But as soon as a VM gets migrated to the new rack or to the new ESXi, network is immediately stopping. Yeah, please verify if the MTU is configured correctly. One last thing I forgotten to mention from the what's new perspective. With the release of NSX-4, we have now the possibility of utilizing different AS numbers in BGP on per VRF. So we have now really possibility that we can have different BGP IS numbers on each VRF and not having the same BGP number on each of my VRFs. Okay.
So,
thank you for your attendance. We are still around, so if you have any questions, just jump directly to us. And thanks.
goodbye.